Good morning, everybody. Thank you to the organizers for inviting me to speak this morning at the Save Our Soils conference. I was able to participate in some of the sessions yesterday, very good quality sessions, and I hope you're enjoying the conference. I'm going to talk to you today about the nexus between our food wastes, our biogenic wastes, and our soils and our agricultural systems. But firstly, let me just put some guidelines down for everybody, because when we think about the future and about sustainability, I just want to give you my ideas about what I think that means. And regrettably, we're still using last century's thinking to try to solve this century's problems. And Einstein, as you know, very well defined stupidity as being the act of repeating the same processes over and over again and hoping for different answers. So we actually have to change radically what we're doing, and very, very, very fast. We are no longer in a situation with the world's environment deteriorating so rapidly and climate change racing forward so rapidly that we can tinker with it. We have to move fast. And the good news is that we have every technology that we need. We have a huge database of knowledge, and we know what we need to do to get our ecology, get our environment back onto a sustainable track. There are no mysteries anymore. And if we can put a spacecraft on Mars and send photos from Mars, this is not so difficult. This is really not rocket science, sorting out some of these issues. The question is that we're using our money wrongly, and we are still financing the destruction of our environment rather than the regeneration. So let's come to climate change and food waste. There was a really great report on the president of the World Biogas Association, which the association put out a couple of years ago, looking at how food waste is managed around the globe and the role of food waste in reducing greenhouse gas emissions. Well, it's a big story. I mean, according to ADBA here in the UK, some 6% of our greenhouse gases can be abated by treating those extra 3 or 4 million tonnes of food waste, which we have here across England and Scotland and Wales and Northern Ireland, putting that into composting, putting that into anaerobic digestion to make biogas and organic carbon to put back to soil. And there are fantastic opportunities there, because from 2020, end of 2023, we will all be obliged to separately collect our food waste. So there's a great opportunity there. However, there's also the challenge of getting it right. We must ensure that that food waste is treated in the right way to avoid ammonia emissions, methane leakage, nitrate runoff, and pollution to our water courses. So it has to be done right. Otherwise, the opportunity is not fulfilled. And getting food waste and our biogenic wastes in general, and by that I also mean a lot of those cleaner industrial, agro-industrial wastes, some sewage sludges, back to soil cleanly has fantastic climate change impacts. The 4,000 or 40,000 campaign, which you probably all know, led by the French government within the Climate Change Action Plan, shows that just 4,000 of organic carbon put back to soil is equivalent to the annual emissions of CO2 from fossil fuels. Now, that's an enormous story. And it's a story which many governments around the world have signed up to, including our own government here in the UK. And so one of the ways in which we can do that is to put organic carbon from our food waste back to soil. The Ellen MacArthur Foundation did a great study on this a couple of years ago called Igniting a Food System Transformation. I really suggest you read it. And what it shows and what it highlights is that just 2% of the food waste and those biogenic wastes which we now have in cities goes back to soil. 200 or so years ago, we all lived on the farm, and there were many, many fewer people than there are today. Now 60% of us and more live in cities, urban areas, And that's where those biogenic wastes remain. They don't go back to soil. We factory farm our animals, so that manure is not evenly spread across our farmlands. So that's what we need to take care of. And by attacking that food waste and bringing it back to soil, we can solve a lot of the climate problems and food security problems that we are facing. So the question is how to do this cleanly. The food system at the moment is contributing to ecological destruction through runoff from farm pollutants, through the greenhouse gases coming from intensive animal husbandry, through the exploitation of soils for intensive cultivation. You know, I was reading recently that we grow maize or corn to feed cows because that is the fastest way for them to put on weight, but that actually corn is bad for the cow's stomach. So therefore, we have to feed them massive amounts of antibiotics to stop them getting sick. And those antibiotics run into our food system and run into our water systems. So that is really a sick perversion that we have made of our food system, feeding animals feedstocks which are bad for them in the name of faster growth meat. So we have to get our heads around things like this. We're losing fertile soil through intensive farming and runoff, and getting that organic carbon back is a way in which we can stop this vicious circle. So compost is a route for this, and it has to be clean, and it has to ensure that it has environmental benefits. You've probably seen this in other presentations, but the decline of organic carbon in our soils, not just here in the UK, but across the whole of Europe, is alarming, ladies and gentlemen. We need healthy soils to have around about 3% minimum plus organic carbon in them to support crops. And as you can see from this map, there is an increasing amount of soil right across Europe, and including the UK, which does not meet that 3% target. But all that organic carbon which we've taken from soil is contained in those urban wastes, those food wastes which we throw away, which we can get back to soil. And what do we want from those wastes? Well, we want lots of energy so that we can produce biogas, biomethane for transport and heating. We want lots of clean compost so that we want to get that organic carbon back to soil to recreate that topsoil which we have lost. And we want to ensure that we don't get, with those processes, lots of contamination. At the moment, we are getting, as the Environment Agency has shown this year, lots and lots of plastic are being spread to soil through compost, through digestate, but also through other farm practices, and they are accumulating in soil and sterilizing our soils. So this is another challenge that we have to face. So when we do our food waste collections, if any of you have ever been to a compost plant or an anaerobic digestion plant here in the UK, this is a very, very common appearance. This is how food waste appears, and closer up, this is what it looks like. Well, you know, you can't make compost and you can't make biogas out of plastics. You have to strip it all out. And so we're getting very, very heavily contaminated feedstocks, which we need to sort out and ensure that what we put to soil is clean. It's possible to put clean bio-waste back to soil. Here is a case from northeast Italy, where they've been doing food waste collections now for 25 years. And they have levels of impurity which range between 0.29 and 0.95%, compared to anywhere between 5 and 15% here in the UK. And they did this back in the last decade by mandating the use of compostable bin liners for collections and compostable carrier bags, thereby eliminating the instruments, the plastic bags, which people could use to take their food waste to treatment. And so this has been a huge success, and the outcome of this is that the highest recycling rates in the world, more or less, and certainly the highest recycling rates in Europe, are where you have the highest intersection of food waste. And Italy is very good at it. of all the food waste collected across the whole of the EU, including the UK, Norway, and Switzerland, 2/3 of that is collected in Italy alone. So a great success story, and one which we can learn from when we're talking about bringing our own food waste and our own biogenic wastes back to soil. So that's the situation we have and the challenge we have ahead. As I say, by 2023, we will all have food waste collections at home. How we get that material back to soil cleanly is critical to achieving sustainability in our soil systems as well as our waste systems. So we're still only getting across the EU around about 16% of those food waste back to soil. But there is an increasing amount of, I think, more future potential than present, but there will be an increasing amount of competition for these food wastes as we move forward over time. And this is because technologies have developed. And these technologies now allow us to take those wastes and produce materials from them, not just compost and not just biogas, but also chemicals. And those chemicals can be used for a series of things, including making, for example, biopolymers and bioplastics. And we're already seeing in certain geographies the competition for vegetable oils, waste vegetable oils, between those who want to take them and make biofuels and those who want to take them and make biopolymers for the chemical industry. And we will see that will happen increasingly over the next decade. The European Union, I'm involved in two projects. The European Union has put billions of euro into research on the use of plant-based materials, including materials from bio-waste, to make new innovative materials such as compostable plastics. And that whole scenario about the ways in which technologies are changing where food waste will go is a fascinating one. I don't have a crystal ball, but I think that there will be a lot more competition. And the future may look like this. This is a traditional bioeconomy, biorefinery model in which we are using some of the byproducts, including, for example, CO2, which is extracted. And that CO2 can now be transformed into solids to make new plastics with. So we can actually extract CO2 from our, for example, biogas plants and use that as a feedstock for new materials. So that is one model. Another model is the model from the Spanish company Abengoa, which I love, and their model is around the use of sugar, and so using sugar, which they call the miracle molecule, to make a whole series of chemical products, going from energy, of course, going in through to chemicals to make rubber, lubricants, and additives. Going up into fuel to help decarbonize some of our transport fuel, including aviation fuel, and also going up here to make plastics and esters, polyesters. So sugar could be one of the ingredients of a new technological industrial revolution. There is also another competing use for food waste. And in Japan and Korea, for example, food waste is commonly used as a feedstock for animals. They centrifuge it, they pasteurize it, they make sure it's clean, get out any pathogens, and then they use it for animal feed. And there is an increasingly growing movement and industry here also in Europe looking at using food waste to become a feedstock for the black soldier fly or other flies, and that larva can then be dried and used, for example, as an alternative feedstock for farm animals, but also for fish, for salmon farming, for example. Much of that is still illegal in the EU because of the animal byproducts regulation, but we're looking at an increasing trend towards acceptability of this technology as we go forward. So there's another technology where food waste will be a competitor, food waste use will be a competitor of the traditional biogas and composting uses. The future may also, of course, look like this. And this is what Central Southern Europe will look like in 80 years' time if we do not act now, if we do not get that organic carbon back to soil. And this is a very, very bleak future. This is where we are heading today by not acting. And this is also where we are heading today, particularly here in the UK, where we consider soil to be a commodity that can be bought and sold, built upon, and little villages become towns and they become bigger and bigger, and farmland gets eaten up. And really, I believe that we have to get to the point where we must ban all new build on farmland. If we have a growing population and a potential food security issue going forward, and we are losing topsoil, and some of our soils are becoming infertile, then we need to protect what we have. And we're not going to protect them by building housing estates. We have thousands and thousands of sites across the UK, which are brownfield sites, which are old built areas where we can demolish old buildings and old areas and build new housing for our people in an urban context. We don't need to spread out across the countryside. And I wonder whether we will understand one day that we can't eat cement. So some conclusions from me about food waste and soil management. There's a lot of food waste that will be available for treatment from 2023, 2024 onwards. That can make energy, compost. It can also perhaps go into other technological developments, as we've seen. We need to do it right, and we need to get it right. And at the moment, the AD and the compost industry don't work in synergy. We need to get them working together so that we get both biogas and compost out of our biogenic waste, get that back to soil cleanly without plastic contamination so that our soils have a net benefit from that. We probably also need to think about the use of our money to incentivize farmers to become carbon sinks, carbon farming, and compost is the easiest carbon farming that we have. And so we might want to think about allocating some of our money instead of to destruction to the regeneration of our soils through incentivizing the carbon sink. That is enough, I think, from me, ladies and gentlemen. I can see there are some points here in the chat. And if there are any questions, no, okay, then I have finished, and I believe that the organizers will have a facility for you to put questions to me should you wish to, and I will be happy to answer them.